We're still in section 2.4, and what we're going to do here is talk about two things. One is the accuracy of a measurement, and the other is the precision of a measurement. So first up, why don't we talk about the accuracy, how to determine the accuracy of an approximate number. Now, an approximate number is a number that results from a measurement. An exact number is an count. Like, okay, there's 1, 2, 3, 4, 5 words right here. That would be an exact number. An approximate number comes from a measurement. Like, okay, maybe if I measure, like from the left of this screen all the way to the right of this screen, that would be a measurement, and that's just an approximation. So what we're going to do is talk about the accuracy of a measurement. So to get the accuracy of a number, what we're going to do is we're going to count the number of significant digits in that number. And there's going to be two cases. Here's case 1. The number has no digits to the right of the decimal point. Let's take this example here. We got 75060. So counting the number of significant digits, now we'll go from left to right. Remember, all non-zeros are significant, so we got 1, 2, 3 at least. Now here's a 0 that is between two significant digits, so it is significant. This 0, however, is not significant because it is not between two significant digits, nor is it to the right of a decimal point. So what we've got here is 1, 2, 3, 4 significant digits. So this number, 75060, that's accurate to 4 significant digits. Now case 2 will say that the number has at least one non-zero digit to the right of the decimal point. Non-zero, not a 0. Let's think about this number right here. We got 3 zeros, 208. Now, let's look at these significant digits here, right? What we want to do is we want to count the number of significant digits. So what about, well, the 2 and the 8 we know are significant. This 0 here we know is significant because it is between two significant digits. So we've got at least 1, 2, 3. Now what about these zeros? Well, these zeros here are to the right of the decimal, but they are not to the right. These are not to the right of a significant digit. So these are not significant. So we have 1, 2, 3. So this number right here is accurate to 3 significant digits. Before we move on to the precision of a number, let's take a look at one more example here. For this number here, 52.160, this is still a case of number 2 because we have at least one non-zero digit to the right of the decimal point. So let's count up the significant digits. We have 1, 2, 3, 4, and this 0 is significant, right? Because it is to the right of the decimal and to the right of a significant digit. So we have 1, 2, 3, 4, 5 significant digits. So this number is accurate to 5 significant digits. So now we're going to take a look at the precision of an approximate number. So the precision, here's what it is. The precision measures how close measured values are to each other. So let's take a look down here. Here we have high precision, right? Because all of these dots are right next to each other. This one down here is low precision because the dots are pretty spread out. They're not close to each other. To get the precision of a number, what we do is we look at the number and determine the rightmost significant digit and what place that's in, what decimal position, like tenths, hundredths, thousandths, tens, hundreds. Let's take a look at some examples. How about this number here, 14.2? Well, all these numbers are significant, and the decimal position of the rightmost significant digit is the tenth place. So we'll say that this number here is precise to the tenths. Let's try this number here, 14.20. So let's look at the rightmost significant digit. Now the 1, 4, and the 2 are all significant because they're non-zero. What about this 0? Do you think that that is significant or not? The answer is it is significant because it is to the right of the decimal and it's to the right of a significant digit. So this is the rightmost significant digit. It occurs in the hundredths place. So we'll now claim that this number here is precise to the hundredths. Now this number 14, this is, the 4 is the rightmost significant digit, and this is in the ones place. So this number here is precise to the ones place, or the units place. This number here, though, 140, the rightmost significant digit is, what do you think? It's the 4. This digit here, that 0, is not significant. It is not between two significant digits, nor is it to the right of the decimal point and to the right of a significant digit. It's to the right of a significant digit, all right, but it's not to the right of a decimal point. So this is our rightmost significant digit, and it occurs in the tens place. Let's do this. In this example here, what we want to do is determine which one of these two numbers is more precise and which one is more accurate, or if they have the same precision and accuracy. How about if I do this? I'm going to write, say, accuracy and then precision. So remember now, for accuracy, we look for the number of significant digits. So the number of significant digits in this number here is, these are not significant, but the 4 and the 3 is. So the accuracy here is 3. And the accuracy over here, we have 1, 2, 3, 4 significant digits. So we've got 4 here. So this one is more accurate. This number here is more accurate. And for precision, we're going to look at the number, the position, the decimal position of the rightmost significant digit. Now, for the first number here, the rightmost significant digit occurs in the tenths, hundredths, thousandths position, and in this one, also the thousandths position. So both of these will have the same precision. So let's just summarize here. For accuracy, that is the number 8.752, and for precision, they have the same precision. Let's do the same thing for these two numbers. Let's take a look at first accuracy, and then we'll look at precision. So for accuracy, all right, we have the number of significant digits. So we have 1, 2. Now these zeros are not significant, right? They're not between two significant digits, nor are they to the right of the decimal point and to the right of significant digit. So what we have here are 2 significant digits. But in this one over here, the 8 and the 4 are significant. Now, here's a decimal and a 0. This 0 is to the right of the decimal and to the right of significant digits. So it is significant. These two are significant because now they are between two significant digits. So we have 1, 2, 3, 4, 5 significant digits here. So this one's going to be more accurate. And for precision, we're going to take a look at the rightmost significant digit. What is the decimal position of the rightmost significant digit? So in this first number, 8400, the rightmost significant digit is at 4, and that occurs in the hundredths place. So this is precise to the hundredths. And over here, in this number here, this rightmost significant digit occurs in the tenths place. So that one's in the tenths place. So this number here is more precise. So let's summarize this. So as far as accuracy goes and precision goes, this 8400 has 2 significant digits. 8400.0 has 5. So the 8400.0 is more accurate. So that's going to be the 8400.0. And not only that, but it is precise to the tenths, which is to the right of the hundredths. So again, this number here is both more accurate and more precise.